now let's talk about kinetic energy that's available in the ocean that we can harvest. And very clearly, there's a lot of waves, and this wave basically, if you stay in one position over here, you will find basically that you will get the change in the height, right? So if you basically make something like this in that design, a tower or a dolphin over here, arm and a float, then as the water go up and down, that float will experience a force that will basically make this rocker arm move up and down. So this can be connected here to a pump. So in this design, he's connecting it with a piston cylinder assembly sitting on a float, and as this guy go up and down, and with the right check valves, you can basically translate this action into a way to pump compressed air, right? And then you can use that compressed air for some other application on the shore. You can also think of this, we can turn this into a water pump, right? Like you can have a way to get water, pump it back into the shore also, and then you can use it for a built-in wheel or something, right? So the point is that you can turn this action into mechanical work. And in that artist impression, basically, here, imagine here, well, those floats are connected directly to an electric generator, where that motion in electromagnetic field will basically translate into electric current, and then you can connect them, and you can build that generate electric power again to the shore. Here is another example to harvest that wave energy. So this remind you of what, like a clam, right? And it's basically with all those cylinder that will experience the buoyancy force. All those things are just to pump that piston cylinder assembly, and then you can use this hydraulic power into a turbine, right? You can send all this water basically into an electric turbine, a hydraulic turbine connected to electric generator, right? So finally, this is an artist impression of how you can also harvest this wave energy, but this is an actual model that they build. And so knowing the wavelengths that you experience in that particular place, then you can design this float with the right position. And again, what's the point? You are using that wave energy to pump for pumping action. And that pumping action could be directly connected to an electric generator sitting over there, or again, just pumping liquid and you can send it to the shore. So there is tremendous amount of wave energy, and there are very creative way that people can come up with, and the criteria to judge whether this is a good design or not is eventually the kilowatt hour price. How much would you pay for the kilowatt hour? And how do you calculate this? Because the fuel is for free. Well, it's the initial cost, and what's the life of something like this? And again, the ocean water is a little bit corrosive, right? Because all the salt content. So whatever you're gonna design need to survive in a very hard environment. So depending on will it live for 10 years or 5 years or 3 years, how much kilowatt hour will it generate during all this time span? And you divide the cost, the initial cost, and whatever running cost that you're gonna basically pay for, like maintenance or operation cost, right? All that cost divided by the total kilowatt hour produced, you will be able to figure basically how much are you paying for each kilowatt hour. And if it's comparable to the alternative, and sometimes the alternative is very expensive, because in many communities where they live on islands, their fuel is very expensive actually, because they have to ship that fuel all the way to that place, right? So what I'm trying to say is that all those designs are not really competing with 11 cents per kilowatt hour that we pay in Oklahoma using natural gas, but they would be competing with like diesel generators sitting in an island in Indonesia or Scotland, somewhere, isolated place in Scotland or Ireland, or where people really would pay the money in order to get the electric power, right?